All right, so this numerical is on the topic of projectile. So you can see a body is projected and it undergoes a projectile motion. The initial velocity of the body is u, and this makes an angle theta. Now, after some time, which is unknown, the body is now in a direction which is right angle to the initial velocity. So if you draw the vector of initial velocity, which is this vector, you could have a situation where, the projectile is maybe at some place where, let's try and show that, place where the projectile is exhibiting the velocity vector, which is, maybe somewhere, close to, let's say this. Okay, so let's say this is the location where the body acquires velocity vector, which is 90 degree to the initial velocity. So if you see, this is the initial velocity vector, and this velocity vector is the representative of the situation where the velocity, sorry, it's okay. So just rub it off and use some different color. I think it's hanging a bit. All right, so this velocity vector, which is at some instant, is at 90 degrees to the initial velocity vector u. And we have to find, the situation or the condition when this is true. So this is your v, which is perpendicular, okay? So let's see, again, more of a vector problem because it expects you, knowledge of vectors. So if this is 90 degrees, okay, if this is 90 degree, so if you have a vector, which is like this on a coordinate system, and then you draw another vector, which is perpendicular to this, and it goes like this. Okay, so this is 90 degree, this is theta. So obviously, as per the triangle, this vector essentially is 90 minus theta. Okay, so if I draw a line, here, okay, I draw a line here. So I know this vector is going like this, and this is 90 minus theta. So I can see that if I have to draw components of this vector, one is in positive x-axis and the y is negative here, right? So this is a velocity vector which is perpendicular to the initial velocity vector. Okay, so let's say the velocity of the body, at this place is v. If you take the components of this velocity vector, this angle is 90 minus theta because these are opposite angles, this angle and this angles, and this is the velocity vector being referred to. So this is one component which is x. So if you write this, it will be v cos of 90 minus theta, and this which will be v sine 90 minus theta. So that after some time the velocity in y direction is downward, and the velocity which never changes for x-axis is v cos, so this will become v sine theta. And your initial velocity is u cos theta in x direction, and in the new location, which is maybe point B, and this is your point of projection, the velocity at the point of projection, the horizontal component is ux, and you can see the horizontal component, at B, this is the velocity representing is equal to v sine theta. Okay, so you can get, so this is also ux, and this never changes. So you can find out that v is equal to u cos theta by sine theta is equal to u cot theta. So again, this was not exactly your test of projectile, because I think you're very good in that. Essentially, this numerical again tries to test your knowledge in the area of vectors. So you can see the vector, one vector, and this is the second vector. These are at right angles to each other. And then you resolve these two. the basic concept you're using is that the horizontal velocity never changes. So I hope it helps. Seemingly, I think we have to work a lot in the area of vectors, and it takes time. I think this is just beginning of class 11th. It takes a while to have a strong grip on vectors. So don't worry and don't take things too hard. Thank you very much.